Hello, everyone. We're going to be talking about the water cycle. We're also going to be able to identify how to the minerals. There's a lot of different types of rock. Well, what is a rock? Well, rock is any solid mass of a mineral or mineral-like matter that occurs naturally as a part of our Earth or our planet. We have three types: igneous, sedimentary, metamorphic. Well, we have to identify the rock cycle. You must know this complete cycle. So, the rock cycle is interactions among Earth's water, air, land, and living things. Basically, it can make rocks from another type of rock. It continues, it never stops. So, the rock cycle shows the interrelationships between the three we mentioned: igneous, sedimentary, metamorphic. Well, we get some rock from magma, we can get something from lava, we get something from weathering, as well as sediments. I want you to pause this video and I want you to draw the rock cycle with the right labels inside of your notes. So pause the video and draw this cycle. Since you drew the cycle, let's talk about these rocks. The first rock is igneous rocks. It forms when lava or magma hardens, okay? If you don't know what lava is, well, lava is the molten rock on the surface of the earth, okay? So when it comes out, that is called lava. Magma is the molten rock beneath the earth's surface, so that's the magma under the earth surface. Igneous rocks are formed through cooling and crystallization. So here is an igneous rock, and this is also an igneous rock. The formation of igneous rocks also has two types of igneous. We have intrusive and we have extrusive. Well, intrusive, the word in, and we understand that magma is inside of the Earth's crust. So, intrusive forms when magma hardens. An example of that is granite. Yes, the same granite that be inside the kitchens. Extrusive, basically giving you the idea of being outside. Remember, lava is what we see on the outside, and this is what hardens. In the example here, we have rhyolite. Now, how else can we identify those between intrusive and extrusive? Well, texture and composition. Like, look at all these colors. Granite, you ever felt granite? You've seen the texture inside? Here's some more igneous rocks. Well, what about sedimentary rocks? Well, this is when it forms when other rocks are broken down into sediments and they're compacted, which means squeezed together, and cemented, which is like a glue. And so again, the process is called cementing and compaction. So here are some examples on the right. We have limestone, sandstone. If you look here, you can see a lot of layers here. So the sediments is what makes sedimentary rock. So we can get these for multiple reasons. So weathering. So weathering is any process that breaks rocks into sediments. We have erosion, the removal of weathered rocks. We also have deposition. This is when an agent of erosion, such as water, wind, ice, or gravity, loses energy and drops the sediment. We also have compaction, which is the process that squeezes or compacts sediments together. We also have cementation, basically what takes place when minerals are deposited into tiny spaces of the sediments and basically make it like a glue. So again, you have to understand that process is the real term for that process is called lithification. So again, compaction and sedimentation. Well, we talked about igneous, we talked about sedimentary. What about metamorphic? Well, metamorphic is existing rocks that are changed by heat and pressure. So remember, metamorphism is like change, and then morph is like your form. So changing your form. Well, what are the agents that kind of pretty much make the metamorphism? Heat. Heat provides energy that can change chemical reactions, which causes existing minerals to recrystallize. Pressure. If it's applied in different ways, it causes different rocks in between the spaces of the minerals and grains to close. And we also have hydrothermal. So we have hydro, okay, and thermal has to deal with a heat. So we have hot water based off the solutions that produce recrystallization by dissolving original minerals and then depositing new ones. So just like igneous, we have intrusive and extrusive. Metamorphic has foliated and non-foliated. So foliated has like layers and bands, and non-foliated has no layers or no bands. So that's more like your marble. And we have seen marbles, and marble is very pretty. This is also classified by its texture and composition. Here is some examples of metamorphic rocks. So how do we actually identify these? Well, you have to identify it by the physical properties such as color and the appearance, the luster, streak, the hardness, cleavage, and fracture. So first let's talk about color. Look at all these beautiful color rocks. Colors can be misleading because some rocks can be the same color. Many minerals will have the same, almost the same appearance, but they have different impurities. So if you just look at a rock, it's pretty much hard to identify which mineral it is because it's not enough information. Luster. So luster basically is how it reflects from light. So metallic, obviously, is shiny. Non-metallic is very dull. Non-shiny can be like pearly, sickly, or glassy. And again, you can see metallic here, non-metallic here. We can also use tower terms such as waxy, pearly, glassy, dull, and silky. Streak. So that would be the color of the powder form of the mineral. So as you see here, there is a streak board. And so the streak plate, once you, regardless of what color it may be, look at the color that it results in. We find material streak by rubbing it on a white ceramic plate. The color of the streak can be different than the mineral, as you see where I drew earlier. Minerals must be softer than the streak plate. If they're not softer, it may not show. Streak can help identify quartz. Pure quartz is clear, blue, but amethyst is purple. Smoky quartz is black, and aventurine is green. But quartz always leave a white streak, regardless. It's always going to be white, regardless of the color of quartz. Hardness is how easily the mineral scratches materials. And we go off of the Mohs hardness scale, so 1 being soft and 10 being hard. As you see here, you test seeing if the material can scratch different objects. So like talc, a diamond. So diamond, we look at the hardness, it is 10. Diamond can scratch. Cleavage and fracture. This is the way the mineral breaks. As you see here, it says cleavage varies with mineral types. Mica, as you see here, can break into sheets. Halite can break at 90-degree angles. Diamond breaks in 4 different directions. So, cleavage, minerals break smooth and flat surfaces, and every fragment has the same general shape. Fracture, minerals break at random with jagged edges. So cleavage is like it needs to be perfect. Fracture, nah, it just is gonna break however it wants. So cleavage or fracture. It's pretty clean, huh? What about that one? What about that? Can you tell me about that one? Look at these. Can you identify if it was cleavage or fracture?